volume of carbon dioxide measured at s.t.p. produced when 1 kg of potassium hydrogen trioxocarbonate 4 is totally decomposed by it. Given the G.M.V, that is gram molar volume at s.t.p, to be 22.4 dm³, atomic mass of potassium to be 39, atomic mass of oxygen 16, atomic mass of carbon 12, and atomic mass of hydrogen 1. Solution. Based on the question given above, we are being made to understand that potassium hydrogen trioxocarbonate is totally decomposed by it. So the first thing to do now is to write out the chemical equation showing the decomposition of potassium hydrogen trioxocarbonate 4. The chemical formula for potassium hydrogen trioxocarbonate 4 is KHCO3. So when this decomposes, we have K2CO3, that is potassium carbonate, plus carbon dioxide, which is a gas, and then steam. So now we've written out the chemical equation. Now next thing to do is to check if the equation is balanced, because without a balanced chemical equation, we won't get an accurate result. So now let's check. The number of atoms of potassium present here is 1, and the previous side we have 2. So to do that, we'll be adding 2 as a coefficient here. So this makes the number of atoms of potassium to be 2 in the reactant side, and in the product side we have 2 as well, so it is balanced. For hydrogen now we have 2 atoms, because this 2 is affecting all atoms present in this compound. So we have 2 atoms of hydrogen. In the product side we have 2 as well. Hydrogen is balanced. For carbon we have 2 as well. So here we have 1, we have 1, 1 plus 1, that's 2. So carbon is balanced as well. And for oxygen, 2 times 3, that's 6. So we have 6 atoms present in the reactant side, and in the product side we have 3 plus 2 plus 1, which is 6. So oxygen is balanced as well. So then we can say we have a balanced chemical equation. Now after writing out the balanced chemical equation, going back to the question, we are being made to know that 1 kg of potassium hydrogen trioxocarbonate 4 was decomposed. So now we are given the mass that was decomposed, but we do not know the moles of KHCO3 that was decomposed. So to proceed with any calculation, that will be the first thing we'll be calculating, so as to have a stoichiometric relationship in our calculation. We have moles to be equal to mass over molar mass. Don't forget that what we are trying to get now is to know the number of moles of KHCO3 that was decomposed. So mass of KHCO3 now, that is potassium hydrogen trioxocarbonate 4. Based on the question, we are given to be 1 kg, which is also equivalent to 1000 grams. And for the molar mass now, so we say molar mass of KHCO3, we will be calculating that since it is not given in the question. Potassium now, we have atomic mass of potassium to be 39. So we have 39 plus that of hydrogen to be 1 plus carbon, which is 12. And for oxygen now, we have 3 atoms present. So we'll say 3 multiplied by 16, the atomic mass of oxygen. So this gives 39 plus 1 plus 12 plus 48, which is equivalent to 100, and the unit grams per mole. We've gotten the molar mass of potassium hydrogen trioxocarbonate 4, that is KHCO3. We've been given the mass of KHCO3, then we are left to calculate the number of moles of KHCO3 present. So we say moles of KHCO3. which is 1000 grams, divided by the molar mass, which is 100 grams per mole. So this gives 10 moles. Having gotten the number of moles of KHCO3 to be 10 moles, then we can go back to the chemical equation to have a stoichiometric relationship, saying that 2 moles here, 2 moles of KHCO3 produces 1 mole of CO2, that is carbon dioxide. Don't forget we are asked to calculate the volume of carbon dioxide produced. So now we say 2 moles of KHCO3 will produce 1 mole of CO2. So 10 moles of KHCO3 now we give X moles of CO2. So to get X now, we'll be cross multiplying indirectly, then X equals 10 moles KHCO3 multiplied by 1 mole CO2 divided by 2 moles KHCO3, which is equivalent to 5 moles CO2. So now we can say that if 2 moles of KHCO3 produces 1 mole of CO2, then 10 moles of KHCO3 will produce 5 moles of CO2. So this is just the first part of the question. Don't forget we are being asked to calculate the volume. So with the moles we've got in here and we've been given the G.M.V of the gas, then we can calculate the volume of the gas, which is CO2, that is carbon dioxide. Let's proceed. To get the volume of carbon dioxide produced, so if we've gotten the number of moles of carbon dioxide that will be produced, then we can use the formula that says moles equals volume over amount at s.t.p. So at s.t.p now, the amount is the G.M.V given, that is the gram molar volume of the gas, which means the volume of 1 mole of a substance at s.t.p, and is given to be 22.4 dm³. Since we've gotten the number of moles of the gas produced and we are yet to know the volume, and that's what we have been asked to calculate from the question, so we can make volume the subject here by saying volume equals moles times amount at s.t.p. Volume of CO2 produced is then equal to the number of moles, which is 5, multiplied by the volume at s.t.p, 22.4. So this gives us 112 dm³. The volume of carbon dioxide produced at s.t.p when 1 kilogram of potassium hydrogen trioxocarbonate 4 is totally decomposed by it is 112 dm³, and that serves as the final answer. Kindly subscribe and click on the notification bell so as to be notified as soon as new videos are being posted. Thank you.